translations. Translations are a specific type of transformation. And let's look at this graph. This is the function of x equals x squared, and we know this is a parabola. X squared gives us a parabola. And it goes through the origin, 0, 0. It's symmetric, so this side will be the same as that. And let's say we wanted to take this parabola and move it over a little bit. So that way, instead of being right here, it's going to be a few pieces over, a few tick marks. Let's say we wanted to move it 2 places to the right, so that the new graph of that parabola, it would be the same exact shape, except it would be over 2 units. So it would come down, it would hit at 2 and go back up. Okay. So, looking at the original function, we have to think to ourselves, how would we move this to the right? A movement to the right will be kind of weird. What you're going to do is you are going to put x minus whatever number you want to move to. So we're moving 2 units to the right. We're going to take where it was. I'm going to say subtract 2, and I know this goes against your common sense. You want to say plus 2 since you're going to move it to the right, but it's going to be a minus 2. So this will move that parabola to the right 2 units. To prove to you that it does, choose this point right here, this bottom, this vertex. This is the coordinate 0, 0, right? For that point, 0, 0. If I would put 0 into that function, I would get 0 squared, which definitely is the number 0. This is your x value, what you're putting in, and whatever number you get as an answer after you do the operations on it, this is your y value. So you're getting 0, 0. Let's say I put 1 in, f of 1. I would get 1 squared, and that would be equal to 1. If I take 2, it would be 2 squared, and that would be 4. This one looks like it's more interesting to use because it's not the same number being generated. So let's use this one. If we put 2 in for x, we're going to get a y value of 4. So this point here is 2, 4. Well, if we start to do the same thing on that side, 2, 4 is not even here. But if we want something that will be at the same height that this was at y equals 4, right? If we want something that definitely is at that same height, we're looking at about something around here. Let's just say this point right here. So here's 3, 4. If every point in this parabola is moved over 2 units, this goes over here, this goes 2 units over, this goes 2 units over, this point should be 4, 4. Because it was at 2, 4, and this point will be moved 2 units to the right. 1, 2. So the x value will become, instead of 2, it'll be 4. So let's prove that this really happens. Plug it in there. So f of 4, we're putting an x value in of 4. We're going to do this math here. 4 minus 2 and square it. 4 minus 2 is 2. And we're going to square that, and we're definitely going to get 4. And this is our y value. So we are going to move that parabola. The whole thing will be moved over 2 units to the right, but you still got to put x minus 2. If you're going to move it to the right, to the left, sorry, to the left, the thing that would move this to the left is, instead of a minus 2 right there, it would become a plus 2. And then the parabola would be moved to the left 2 units. So our original parabola, if we looked at it here, could be moved over 2 units to the left. So our parabola will look like this. If this is a plus in there, x plus 2 quantity squared. So that's basically translations.